Greetings to each and everyone. This is Group A. Today we are going to tackle about codes that includes basic logic gates, encoding and decoding, and repetition and having codes. Today's topic is entitled The Enhancement of Codes with the theme Breaking Codes for a Bold Future. Here are the objectives for today's discussion. First is to debate, recognize and comprehend the nature of codes. Second is to master many sorts of coding techniques for encoding and decoding on information, and to use these strategies to identify privacy and security. And this is the conceptual framework. Cracking codes and deciphering secret communication requires a lot of math, from fundamental addition and subtraction to data handling and logical thinking. Let us talk about codes today and how they are used. Hey Trish, I've been watching you. Are you studying?
Yes, Grace, but I have a hard time understanding this topic.
What is it about? Maybe I can help.
It's about the codes. Look, this one.
That's a familiar lesson. Actually, I'm currently learning the topic too, and I've been tuning in this video presentation about codes. Perfect timing. Do you want to watch this educational video with me?
Sure, maybe I could pick up something.
Here, look.
Hey, it's Danica.
And this is Ella. And today,
We will talk about codes.
first, let us talk about basic logic gates.
Did you know the basic logic gates? Digital systems are said to be constructed by using logic gates. There are 7 basic logic gates which are with the aid of truth tables. The first, AND gate. The AND gate is an electronic circuit that gives a high output only if all its inputs are high. Second, OR gate is an electronic circuit that gives high output if one or more of its inputs are high. Third, NOT gate is an electronic circuit that produces an inverted versions of the input at its output. It is also known as an inverter. Fourth, NAND gate. In the figure shown, that is a NOT AND gate which is equal to AND gate followed by a NOT gate. The outputs of all NAND gate are high if any of the inputs are low. Fifth, NOR gate, also known as NOT OR gate, which is equal to an OR gate followed by a NOT gate. Sixth, XOR gate, a circuit which will give a high output if either but not both of its two are high. The last one, the XNOR gate, a gate circuit that does the opposite to the EOR gate. In summary, the following figures and truth tables are presented.
Now, let's talk about text data. Textual data is material that has been methodically collected and consists of written, printed, or electronically disseminated words that have been either purposely written or transcribed from speech. Text mining uses statistics, linguistics, and machine learning concepts. Encoding and decoding. Encoding and decoding are employed in many types of communications, including computers and data transmissions. Communications, programming, digital electronics, and human communications are all areas of study. Encoding is a process of putting a message into a form that can be communicated representational design with the goal of ensuring that the receiver understands it. Decoding entails carefully listening to and reading directions. Here we have few following that includes in encoding and decoding. First is errors and error corrections. The process of detecting faults in sent communications and reconstructing the original error-free data is known as error repair. It ensures that messages are received in a correct and error-free state. ARQ is an error control method that employs error detection codes, as well as positive and negative feedback acknowledgement. The figure is an example of ARQ. Second is error decoding codes. Error detection refers to the method used to discover noise or different impairments added into facts, even as it is transmitted from source to destination. The oldest method of error correction involves the use of parity. It works by appending an additional bit to each character phrase sent.
Wow, that's a very informational video.
You could say that, but there's more you need to know. Would you mind me explaining about the parity bit as a continuation of the topic?
I don't mind, go on.
Well, basically, parity bits is a bit appended to the information of binary bits to make certain that the complete number of i's in the facts are even or odd. Parity bits are used for error detection, and it has two types. First one is the even parity. The number of bits with a value of 1 are counted. If that number is odd, the parity bit's value is set to 1 to make the total number of ones in the set, including the parity bit, an even number. The second is the odd parity. It is referred to the parity checking modes where each set of transmitted bits has an odd numbers of bits. If the total number of 1 is in the data plus the parity bit is an odd number of ones, it is called odd parity. The figure is the representation. The repetition codes is one of the most fundamental error correction codes. To do so, the aim of the repetition code is to simply repeat the message numerous times over a noisy channel that may contaminate the transmission in few spots. The figure is representation of repetition codes. Next is checksum. Checksum is an error detection method that is a modular arithmetic sum of message codes, words of fixed word length. Checksum schemes involve longitudinal redundancy checks, parity bits, and check digits. The figure shown is a representation.
Hey Grace, Trisha, I heard you wanna walk air. Are you studying codes? Yes, and Grace is telling me about the topic. Can I sit in? I'm planning to study the same topic as well.
Yeah, no problem. We're actually down to another topic now. The repetition and having codes and so on.
I know the topic also well. Should I share it to you?
I'm glad you do.
Okay then, I'll tell you about the repetition and Hamming codes. Hamming code is an error correction system that can detect and correct errors when data is stored or transmitted. Error correcting codes seek to identify when an error is introduced into some data. This is done by adding parity bits, redundant information to the data. It is named after its inventor, Richard W. Hamming. Ever wondered what is an error? A transmitted data that can be corrupted during communication. There are three types of error. First, single bit errors. The change made in one bit in the entire data sequence is known as a single bit error. Second, multiple bit errors. In data sequence, if there is a change in two or more bits of a data sequence of transmitter to receiver, it is known as a multiple bit errors. Burst errors. The change of the sets bits in the data sequence is known as a burst error. Now, for the Hamming code structure, recall that all bits positioned that are powers of 2, 22, 21, 23 are marked as parity bits, and other data bits are for data bit. The value of parity bits is determined by the sequence of bits that is alternatively as check and skips. If the receiver did not get the correct message, there must be an error in the message. We can use Hamming code to detect and correct the errors.
Ah, I know that. Should I give an example? Okay, so let's have an example. A sender gives 4 data bit 1101 to a receiver. Determine the value of parity bits. Solution is shown in this figure. Find the values of each parity bits. For P1, from P1, check 1 bit, skip 1 bit, check 1 bit, and skip 1 bit. This is how you do it. For P2, from P2, check 2 bit, skip 2 bit, check 2 bit, and skip 2 bit. This is how you dot it. Since the sequence is only up to counting number 7, then we will now determine the value of the parity bit. To complete the structure, the sender transmitted the message below to the receiver. Redundant bits are extra binary bits that are generated and added to the information, carrying bits of data transfer to ensure that no bits were lost during the data transfer. The number of redundant bits can be calculated using the following formula. Let's have an example. Suppose the number of data bits is 7. Then the number of redundant bits can be calculated using this formula. Thus, the number of redundant bits is equal to 4 bits greater than 12.
That's right. Lastly, the repetition. Repetition as a code happens because sometimes one code may be repeated for every data bit and multiple times and can be checked if it was sent correctly.
See, these codes makes math practical. By producing codes for simple programs and automates machines, people are not only seeing the immediate results of their math work, they're also learning a real-world skill.
Anyway, thank you so much for helping me. I've learned a lot about you guys.
No problem. We are here to help one another.
That's right. Anyways, I say goodbye now. See you around.
Bye!